Hello everyone, and welcome back to the continuation of our industrial warehouse design series in which we are going to continue our steps towards modeling the warehouse. And of course, I want to mention that this video is part of a tandem video series, which basically has both theoretical and modeling aspects. I will link the playlist on the top right above. And today's video, we are going to basically add some claddings. I'm not going to add loads yet. We are going to add some claddings. And of course, once we add our claddings, you will notice that we have all kinds of problems when we come to the distribution of loads. So this is going to be fun, although it's only going to be limited in terms of what we're going to cover. There is a lot to basically learn of it. So with that being said, sit back, relax, and enjoy the show. Alright, so now it's time for cladding. So to do this, I will just basically go to geometry and go to cladding. I will not do any shells because claddings are going to be done via ready-to-use sections, so I don't need a shell because I will just, in real life, I will order the cladding from a factory, and basically that's that. It's going to be called from claddings. Okay, so now we're going to draw a cladding, and there is all kinds of problems that will happen to you when you draw the cladding. So I will click on contour, and I will start clicking to draw my cladding. So one here, that's at least one of those spans. One here, one at the apex. I need to be careful where I click, and one here. Okay, so that's my cladding. Oh, wait, I need to click the last one, right? Okay, and the final point is here, and now I have a cladding. And of course, the first thing that you may notice is, wait a minute, the cladding is below the purlins. So will the purlins feel the forces of the claddings? Well, the short answer is yes. And the long answer is, let's find out. So now I'll just quickly add me a load. Notice we're not yet adding any real loads. We're only dealing with dummy loads. So I'll add me a 10 kilonewton per meter load here. And now let's run the analysis. And of course, spoiler, you're going to be disappointed. So let's run the analysis very quickly. And of course, it will run the analysis, hoping that there's no errors. Okay, and now we have our analysis completed. Now, to just show you why there's a problem, if I go to Maps, Diagrams for Members, and open MY and click OK, you can start seeing it. Of course, I need to normalize. You should start seeing it. If you don't see it, then, yeah, there we go. So take a look at this. There is a movement diagram on this element. That's a problem. But why? You see, the problem is, if you just trust the software without double checking, then you think you have done everything right, but in fact you're doing nothing right. What do I mean by this? Well, if you right click on this is your bracing. If you right click on it and go to Object Properties and then select NTM and open MY, you see a moment diagram which shouldn't be there. Now I know what you're thinking. Your defense here is to say, well, it has a self-weight. No, that's not the moment diagram of the self-weight. It's not because of the self-weight that you have a moment diagram here. To prove this to you, I'll go to load table, and just delete the self-weight. Of course, I need to remember that I need to add it back again. So I delete my self-weight and also this. This was a previous load. And now the only load that exists is the distributed load on the slab. And if you run the analysis now, if your defense was, well, this element has self-weight, you will notice that there should be 0 without a self-weight, but that's not the case. You will still see a moment diagram here. So it seems that the moment diagram here is not because of self-weight. So why did a moment diagram happen? Well, it's much more sinister than this. If you right-click and go to Display and go to Loads, there is an option to open the load distribution regions and even to open the forces generated automatically. If you say Apply Now, you will start seeing the problem. The problem is that Autodesk Robot just applied the forces of the cladding on all the elements. Now, this is really cool in other circumstances, but in our circumstance, it's absolutely unacceptable. What happened here is that because you have a cladding, Robot just distributes the load of the cladding on all the elements that surround the cladding. What do I mean by this? If you go to top, you can see it. You see, for example, this has one rafter, a purlin, and a bracing. And you can see Autodesk Robot creating triangles and trapezoids to distribute the force between the rafter, the purlin, and the bracing. And that's, of course, incorrect, because A, the rafter should not feel the force of the cladding, And B, the bracing should never feel the force of the cladding. The only things that should feel the force of the cladding are the purlins, because the cladding is resting on top of the purlin. You see, that's the point of being very, very careful when you deal with structural analysis softwares. If you're a long fan of this channel, you know that I keep screaming my lungs out speaking about this. You must pay attention to the software and pay attention to the results you get. It's not just, hey, there is a diagram, everything looks cool, because it's not always the case. Sometimes the results look cool, but your underlying assumption is bad. And that's the case in my structure today. So, okay, it seems I messed up. Now, the only thing that remains is I need to let those elements, the rafter and the purlin, not see the cladding. So how do I do this? Well, let me first of all show you how I can do this. So if you click, for example, on this bracing, you click on it. So it gets highlighted. Yes, it gets highlighted, right? If you go down to the model, there is something called trapezoid and triangular method analyze. This means that for the triangular and trapezoidal method, this member is visible and will be analyzed. If you select ignore, then and run the analysis again, then you have solved only part of your problem, but at least it's one part in the correct way. So if you click on analysis, you can see now that indeed the trapezoids, for this element at least, the trapezoids and the triangles totally ignore it, so this is one problem solved. But what about the rafter? The triangle is still being applied on the rafter, although that's incorrect. The rafter doesn't feel the cladding, the rafter feels the purlins. So maybe if I select the rafter and select ignore, then it would solve my problem. And the answer is yes, it will solve my problem. So it turns out that I have to select all the elements except the purlins and click on ignore so that the forces are not transferred to those elements. Now, how do I do this in the quickest possible way? Well, the quickest possible way is not to mess it up in the first place, but the reason why I messed it up intentionally is because I want to warn about those possible errors. Now, I remove the cladding and I will run the analysis very quickly, and you can see that everything turned back to zero because, there is nothing. So let me go to geometry cladding very quickly and do one big cladding just to show you the mess that is the error. Of course, you can select one way, but I will keep it two-way, and I will force it to become one way in a moment. So I'll click 1 point here, 1 point here, 1 point here. I'm doing one generalistic cladding for the entire structure. 1 point here and 1 point here. So yeah, now if we run the analysis once again, you will have all kinds of problems. Let's run the analysis and see. Oh, it didn't work. Okay, I think one big cladding just overkills the entire system. So I think I have to do it. That's annoying. I think I have to do it one by one. Oh my God, this is... in the end, I'll just deal with it myself and upload it. So contour, this is 1. Oh wait, I clicked 2, 3, and 4, and 5. Okay, let's run again, analysis. Will it work? Wait, what? It doesn't work. Why? Oh, maybe because I have a no loads? Let me just check. It just worked, right? Why is it not working today? Let me just try it again. Maybe that's the reason. Let's run the analysis. Okay. I'm kind of surprised that the robot does take offense when you define a cladding without a load. Like, this is, I don't know. I'm really surprised. Okay, so, well, let's do it again. Remember, I'm adding a placeholder load. This is in no way, shape, or form the real load. Let me run the analysis again, just to make sure. Yeah, now it's not taking offense to it. Nice. So, okay, of course, now here I have just put one cladding to save time, and you can see once again the bloody mess that is, of course, the trapezoidal stuff that is happening here, which kind of doesn't look good. So we need to fix that. To fix that, we need to ignore everything. We need to let robot ignore all my elements in the analysis of trapezoid and triangles except the purlins. So how do I do that? Well, I select everything like this, and then I will go to my selection tool, and I will select my Z channel, because I selected the Z for the purlins, and click negative, which means remove or subtract from the selection. If you click this, then all the elements except your purlins are selected. And you can now ask robot for all those elements except the purlins to ignore. Let's say OK. Yes. And let's run the analysis now. And let's take a look if it works or not. Okay, so the analysis is complete, and from the looks of it, I think it does work. Well, let's go to top. Yes, perfect. This is beautiful, because now the only things that feel the forces are the purlins. This is exactly how it should be, and I'm happy now. Of course, the bracings don't have any moments. Let me just double check. Click on this, right click, go to Object Properties, and select NTM, go to MY. Yes, the moment is 0. So yeah, now I need to continue cladding everything. So, well, let's go to Geometry Cladding. So now I have my claddings. I'll just quickly go to Loads, Load Table, and delete all the loads. And now I'll just go to, I don't know, I'll just basically go to Loads. I'm making a dummy load now. So I'll make me a dummy surface load of -10 for the cladding. So I'll select those two things. Of course, I selected claddings and nodes and whatever, but it will only apply the forces on the cladding. So yeah, that's perfect. And now I will add me a force in the x-axis being 1 kilonewton. This is just a dummy force. I'm just testing things. And I do this because I don't want to get any bad surprises at the end. This is basically, I suggest to you that you do the same thing when you analyze. When you analyze structures, like you should just have a dummy force ready to apply on your structure to make sure that it behaves as it's supposed to be. So now I have my forces. Did I mess up? I think I messed up. No, I didn't mess up. Okay, it's just a scale thing. Okay, let's run the analysis now. Let's take a look. Am I happy with this? Let me just check. Okay, the load distribution regions are on the purlins as they are supposed to be. Similarly on top, similarly on this. Yeah, I think I'm happy now. Okay, so my structural model of the first warehouse is complete for the first warehouse. But that's not the only warehouse I want to do. It turns out I have multiple warehouses planned for you, dear viewer. So if you thought I'm going to just give up and tell you, hey, let's design and blah, 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 I would be very lazy because that's not what I want. I want to have multiple warehouses to be discussed with you. So this is the first warehouse model, which is a simplistic warehouse, open from both sides. It's just a hangar. Nothing is closed, and it doesn't have any cranes. Now I want to take this to the next level. So I'll select this, go to Edit, Move or Copy, and I'll copy this to the side, and I'm gonna take it like, I don't know, 50 meters to the X, just because I feel I want to throw it away. So I have one, wait, what? Why do I see point loads here? What is this? Wait, I'm kind of worried now. I see point loads. Is this the reaction? No, wait. I see point loads here, and now I am a little bit worried. What are those point loads? Why do I have them? Right click. Let's run the analysis now. Maybe it's just a thing. Maybe it's just a mistake. Let's run the analysis now, just double checking. Why do I have point loads? Claddings should not produce point loads. Claddings should produce distributed loads, right? Yes, it's separate structure. Continue, please. Okay, I see point loads. This calls immediately to an investigation. What are those point loads? Let me just check very quickly. Are those reactions? Oh, wait, I can see something here. Wait. Something is happening here. Something is being distributed here, and I have no idea why. Why does the ground get a distributed load? Is this a bug? Or is it automatically doing something for the... Okay, let me test this. I will just take this support and go to geometry, or just go to supports basically, and remove the support. Is that maybe the case? Okay, I have removed this. Let's run the analysis. Okay, so this purlin is taking half the load as it's supposed to be. Okay, I think I know why. I think Autodesk Robot, it's really strange for me. I'm surprised. Look, the reason why I stopped and immediately looked why this is happening is because I was surprised that I see some forces on points. It turns out that if you have a support Robot will load the support. That's odd. How do you solve that, right? You solve this by having your supports not touch the cladding. Okay, fine, you win. I'll just do it very quickly. Now, I am being a perfectionist here. You do not need to do this. You could ignore and just go on with your life, but I don't know. I just can't get over it, right? I select my entire purlins, trying to be OP. No, wait, what? Okay, and now I'll add me a load of 1 kilonewton. I'll just do it for one side because I want to see if that's the case or not. So 1 kilonewton, I'll add close, and that's on the, and this is something I haven't scripted. I'm surprised really that I get a load on the node. And now basically the mode of truth, right? So right click, display, and I'll go to loads, show those two things, and take a look and hope that, fingers crossed, I think it solved the issue, right? Did it solve? Okay, no loads at the base, check. And here, let me take a look here. Here I have the loads, right? Because I saw them. But here I don't have the loads. So I think yes, I think okay. Okay, I think that, no, I'm really surprised, I'm genuinely surprised. But I think that Autodesk Robot just, you have a support and you have a cladding, it just distributes part of the loads of the cladding to the supports, which is news to me. I have never expected that, but well, it happened, so now we know how to do this. Of course, now the editor is going to speed this up. I hope that this time it works. I didn't expect this to take so much time, to be honest. I was honestly thinking, yeah, this week's video is going to be simple and I'll just finish it in 10 minutes. But every time I say this, I jinx myself and I get into this. Well, I guess that's life. Okay, so let's take a look. Here, I think I fixed the problem. Okay, fine. I think now I'm happy. So in case you're wondering, I will keep this here just because I want to. So okay, that's my second warehouse now. And what do I want to do in my second warehouse? I want to make a crane. Now the crane loading will be done next video, but at least I need to prepare the crane infrastructure. So to prepare the crane infrastructure, I need to add a crane rail. And I will assume that the crane rail is being held by the column. Now there are two options to do this. Option one is to basically do it as it is done in real life. Option two is make an offset. Now I want to do it as it's done in real life, which means I would extend a small beam and put a rail or a runway on that beam. Of course, here the details need to be taken from the crane provider. I will have to assume stuff. I don't know if it's correct or not. It depends on the region, it depends on your crane provider. So please go and check out those things at your provider. So let's do this. Now, of course, there is a vertical clearance for the crane. I'll assume the vertical clearance to be 1 meter. I don't know, you need to check your crane provider. So now I will just assume 1 meter is kind of low. I'll assume the crane clearance to be 1.5 meter. So in the z-axis, I had 8 meters, which was my eaves height. And if you have a vertical clearance from the eaves height of 1.5, then you have a crane height of 6.5 meters in the Z. I'll apply that and close, and you can see that suddenly I have a new Z axis defined. Now I will remove everything because I want to focus on what I'm seeing. So where is my Z? Of course, the editor is now laughing it out. I know he loves it when I just get frustrated. Okay, so imagine, oh my God, imagine I would have drawn the entire thing and then realized I messed up. This would be really hard. Okay, so fine, I think now 1.5 is okay. And now I need to provide my beams. So how do I do this? I have a cool idea. So, and follow me with this. I will go to my 3D XZ, because it looks kind of cool. So I go into 3D XZ and you can see this drawing, right? You can see the 3D XZ being highlighted. Now, can I go to structural axis 0? I have structural axis 0. And now I will add me an axis in the x of 1 meter. 1 meter is too much, right? 1 meter is too much for a runway. I'll just add me a 0.7 meters. I am winging it because I don't have data. You see, it's not like I'm too lazy. It's just I don't have data. So I have now at x equals 0.7, and at the other side I would have 30 minus 0.7, which is 29.3. I'll add that, apply. Do I see it now? I think I see it. I'll go to xz, and now I definitely see it, right? Yes, there we go. So now I'll go to my beam, assume me a steel beam. I'll assume me an IPE section similar to my column. What was it? Was it 550? Well, let me just check. Right click here, properties here, and it is 550, yes. So I'll do the same section as the column, because why not? Also because of realistic issues. So one click here, that's a beam for me. Similarly, I have to click one click here, and that's my beam for me. Now I will assume my runway beam to be exactly on top of here. Now, truth to be said, the runway beam should be a little bit inside, but you can add a node yourself if you want. So I have my two beams, right? If I open the section, okay, they look beautiful. Do they look beautiful? Is it enough? Is it enough clearance? I'm second guessing myself now. 1.5 meters. I have 25 centimeters here and 25 centimeters here. I have the perfectionist inside me kicks in, so I need to do it myself. You see, that's why nobody wants to be my junior engineer. So I'll just select this, and I'll go to edit, move or copy. You see, it just looks wrong, you know? So 0, 0, negative 0.5 meters in the Z. I'll move that, I'll execute, and I think now I'm a little bit more happy. Okay, I think now I'm happy. Just because I like to see my axes where they're supposed to be. Fantastic, now I'm happy. So okay, let's go back to view. Let's select the 3D view now. And now I can see one of my runways. I go back to fully 3D now. So how can I make my runway? Well, I can do it as follows. Assuming that I know the beam size of the runway. Assuming that I know the beam size of the runway. Let's say it's IPE 550. I select my IPE 550, keep it selected and ready. And now, while this is open, or basically I just select it and close, now my IPE 500 is the active section. I'll select this, my beam here. I selected 3 nodes. Why? I should have selected only 2, right? I think I selected 1 extra node. Let me make sure I'm selecting exactly what I want. So if I select this, I select 3 nodes. Why do I have 3 nodes? I should have only 2. Why do I have 3 nodes? Am I messing something up? I should have 1 node here and 1 node here, 2 nodes. Oh, wait. That's worrying. Why do I have 2 nodes here? Why do I have, okay, I have 2 nodes. Okay, this is wrong. I see now why. I know why this happened. Oh my God, this is infuriating. The reason, oh my God, look, and follow me with this. See, my perfectionism basically came back to bite me. Look, when I moved this half a meter, guess what happened? The node that I defined here overlapped with another node. So now I have 2 nodes here, which will basically break my analysis. Oh, come on. Control Z, Control Z, Control Z. That's a short crane. There is no way. That's a short crane. That's too short. That's too small. Let me just select here let me just remove this and click here to see the Z-axis coordinate. 5.75. 5.75 crane height. That's small. That's small cranes. That's itsy bitsy small. But well, you get the idea. I mean, you can just increase the length of the height of the column, but I didn't, so I will not do it because I think enough is enough, right? So, okay, so now I have my beams here. I will select this. I have a better idea. I select this without the node at the start. And I'll select this without the node at the start. And follow me with this. I'll go to edit, move or copy, and I want to copy it 8 times, dragging it. And with a movement vector from one bay to the other. Will it work? Yes, it did. This is amazing. Okay, so I made a runway beam. So go to offset, addition attributes, offsets, and I'll offset it to lower flange, apply. Oh, yeah, of course. I need to offset it lower flange and okay, fine. So I'll just double click this. I'll add lower flange me or something. And it's relative. And it's with respect to this element. And the axis is going to be a top. Okay, add, close, and select. And there we go. Wow, right? It looks cool, and this time, usually I tell you it looks cool, but it's incorrect. No, this time it looks cool and it is correct. And now I have my lower flange runway. What else remains? Well, what remains is to brace. Because my bracings now are incorrect, according to the reference, I should brace now at 2 points, one bracing for the runway and one bracing for the rest. So I'll do it with an X bracing and a V bracing or something. So yeah, that's the runway beam. So I prepared this for the runway beam. Now, if you run the analysis, if you think you're happy, right? You think I'm done. I am not done. I actually messed up. So if you run the analysis, you think everything seems to be fine, but no, I have actually messed up 2 things. And you want a plot twist? So there we go. Here is your plot twist for you. You think everything is fine, there is no instability, so what is he yapping about? Why is he saying I messed up? I messed up because if you go to display, once again, to loads, and those 2 things, if you enable this at least, you can see once again that, hey, there is a total mess up with regard to this. So what gives? Why did you mess up? So you can see that I messed it up here, basically. Why did I mess it up here? Because the cross bracings are basically being loaded. But wait, didn't you mention that the cross bracings should not be loaded? Yes. Why are they loaded? Well, because I have deleted them and I need once again to select them and ask robot to ignore them. So well, I'll just go to my selection tool. This is annoying, right? Not only this, do you know that not all have the release? I released them, I guess, pin, but now because I added new ones, I need to re-release them again. And also I need to go to the analysis somewhere here and ask it to ignore. And now, after all this, if you run the analysis, now you can say, yes, I'm happy. And now you can say that it worked fine. There might be some little issues here and there, but I will just ignore it now because I think more accuracy than this would hurt me rather than help me. So I think, yeah, I think now everything seems to be fine, yes. Yeah, okay. What is this? Wait, what? What is this? What is being loaded? Right click, display. It seems I finish one problem, I get another problem. Loads on nodes. Okay, I think I know what happens. I think my opinion here is whenever this cladding sees a node, it immediately tries to give it loads. You know what? Click here, go to one way, and force it to one way X. But wait, where was my X? I forgot. Let me just check very quickly. X was horizontal, so Y, one way Y. So let's run the analysis again. I'm trying to be basically accurate. Ah, there we go. Oh man, finally. Wait. Is it finally? Is it over? Yes, it is. Okay. I was afraid because I saw this color. I thought there is no distribution because I was expecting different colors. Well, it turns out this is just a coincidence. Just by coincidence, robot just ran out of colors. That's the reason why. You can see it actually from here. You see, I was worried that I didn't see colors here, so I thought it got not distributed. But no, it got distributed with the proof of this load. But I'm just unlucky that robot just ran out of colors, I guess, or something. So, yeah. What about this? Well, same thing applies here. So I think, wait, where is the force? I don't see the force here. I'm panicking too much. This video was really tiring, to be honest. Okay, it's on the other side. Of course, silly me. I defined it that way. Okay, so I think I will stop until here. I still have to do a gable frame, so I need to make a third structure with a gable frame because I want to have three structures. One pure, one with a runway, and one with a gable frame, and basically just have all of them. So at least now I'm ready to apply. So I'm currently ready to apply loads, and I need to do some gable frames. And this is gonna be happening next week. So I think I'm done for now. This was a really stressful video, to be honest. But well, it is what it is. So of course, before I finish, I want to give a huge shout out to the dear channel members whose names are going to be shown on the screen. I would like to thank you very much for all the supports you give to the CE channel, which of course enables me to produce those videos. And for that, I am really, really thankful. In the end, if you have enjoyed the video and you found it beneficial for you, then please like, share, comment, and subscribe, especially subscribing because it helps increase the reach of my channel. As per usual, this is the Civil Engineering Essentials channel, and we'll catch you in the next video.